Good morning. Engineering chemistry, starting with the topic spectroscopy. Okay. Before discussing spectroscopy, we have to know what is electromagnetic radiation. Electromagnetic radiation. What is electromagnetic radiation? So, when particles like atoms or molecules, which are electrically charged, moves under acceleration, alternating electrical and magnetic fields are obtained. Okay, and they are transmitted in the form of waves. These are called as electromagnetic radiation. Okay, when particles like atoms or molecules which are electrically charged, which are electrically charged, moves under acceleration. Moves under acceleration. Alternating electrical and magnetic fields are obtained. Okay. Electrical and magnetic fields are obtained and what happens? And they are transmitted in the form of waves. So they are called as electromagnetic radiation. And these are transmitted in the form of waves. Okay. In the form of waves. Now, what is spectroscopy? Spectroscopy deals with the interaction of atoms or molecules or matter with the electromagnetic radiation. Okay. Spectroscopy deals with the interaction of atoms or molecules or matter with electromagnetic radiation. Okay. With electromagnetic radiation. Now, these molecules possess different quantum mechanical energy states. Okay. Molecules possess different quantum mechanical energy states. Like electronic energy state, then electronic, vibrational, rotational and nuclear. These are the different energy states possessed by molecules. Okay. Now, when radiation falls on these molecules or atoms, what happens? The transition of atoms or molecules occurs between these different energy states. This by the absorption or emission of radiation. Okay. The transition of atoms or molecules between the energy states occurs by the absorption or emission of radiation. Okay. So like this transition takes place between the different energy states. Okay. Now, these transitions are occurred according to some quantum mechanical selection rules. Okay, due to this transition, what happens? Different spectras are obtained. Different spectras are obtained due to this transition. Okay, so spectroscopy involves this production, then measurement, interpretation of this electromagnetic spectra due to this absorption or emission of radiation of electromagnetic radiation. Okay, so this spectroscopy, so different spectra are obtained due to this absorption or emission of radiation, and spectroscopy deals with how to produce this, then interpretation of this, and measurement in an interpretation of electromagnetic spectra due to this emission or absorption of electromagnetic spectra, radiation of atoms or molecules. Okay, now by this we can determine the structure of different substances. Okay, so by identifying the spectra we can determine the structure. Okay, we can determine the structure of different substances. Okay, structure of different substances. So different substances give different kinds of spectra. So by identifying these spectra we can determine the structure of different substances which are obtained by the analysis of molecular or this atomic spectra. Okay, by this spectra, by this molecular atomic spectra, we by identifying that we can determine the structure of different substances. So this is very helpful in the modern chemistry. Okay, so spectroscopy is very helpful, and the instrument used for this purpose is called as spectrometer. Spectrometer. So spectrometer is used to determine the different spectra of different substances. Now this is very helpful. Spectroscopic methods are widely used nowadays because of certain important applications, by certain uses. Okay, now let us discuss that. So spectroscopic methods are widely used nowadays because they require very less time for analysis. Require less time for analysis. Also less sample quantity is required. Less sample quantity. Third point, the sample materials remain unchanged. Okay, so they can be reused. They can be reused because they remain unchanged. Okay, also they give accurate results. Accurate results. Due to these reasons they are widely used. Now next, applications. Applications. First point, radio frequency spectroscopy. They are used in radio frequency spectroscopy. Used as radio frequency spectroscopy. This is used in medical imaging technique called magnetic resonance imaging. In medical imaging, used in medical imaging called as magnetic resonance imaging, MRI. Magnetic resonance imaging or MRI. It's very helpful in this field. Okay, first application. Now second application, microwave spectroscopy. Microwave spectroscopy. That is used to discover 3-degree black body radiation. Okay, discover 3-degree black body radiation. Okay. This is remnant of Big Bang theory. Okay. These are the important applications and uses. Now, based on nature of interaction, based on nature of interaction, nature of interaction of atoms or molecules, either absorption or emission. Spectra are divided into two. Divided into two. First one is absorption spectra. That is absorption spectra. What is absorption spectra? And second one is emission spectra. Absorption spectra means when an atom or a molecule undergo transition from lower energy level to the higher energy level by the absorption of energy, that is h nu amount of energy, a spectra will be obtained, which is called as absorption spectra. Okay, transition from, here the transition is from lower energy state to higher energy state by absorbing energy, that is h nu amount of energy, by absorbing energy. Okay, so transition occurs from final state, initial state to the final state. Initial state is lower energy level and final state is higher energy level. So by absorbing h nu amount of energy, what happens? The transition occurs from lower energy state to the higher energy state, and spectra, absorption spectra is obtained. So such spectra are called as absorption spectra. Now, second one is emission spectra. Here what happens? Here the initial state, initial energy state is higher energy state. So transition occurs from higher energy state to the lower energy state by emitting h nu amount of energy. Okay, by the emission of energy. Transition from higher energy state to lower energy state by emission of energy. Emission of energy. Okay. So transition occurs from higher energy level to lower energy level by the emission of energy, h nu amount of energy. So here the higher energy level are more populated than lower energy level. And in the case of absorption spectra, the important spectral techniques like UV visible spectra, UV visible spectra, then IR spectra, microwave, IR, then microwave technique, and NMR. These are the different techniques belong to this absorption spectra. UV visible, then IR, microwave, and NMR techniques, UV visible techniques, spectroscopy technique. Okay, these techniques are used for absorption spectra. What about emission spectra? The spectral techniques like hydrogen spectrum, then AES, that is atomic emission spectrum, and third one fluorescence spectrum, etc. Fluorescence spectrum, etc. are the techniques used for emission spectra. Okay, so based on nature of interaction, they are divided into two: absorption spectra, where the techniques used are UV visible, then IR, microwave and NMR, and emission spectra, second one, the techniques used are hydrogen spectra, then atomic emission spectra and fluorescence spectra. Okay, etc. Next, second division. Second division is based on the nature of interacting species, that is atoms or molecules. Spectra is divided into two based on the nature of interacting species. Interacting species. Atoms or molecules. They are divided into two. First one, atomic spectra and molecular spectra. What is atomic spectra? The transition of electrons takes place between the atomic energy levels. Okay? Transition of electrons between the atomic energy levels. What about molecular spectra? Transition of electrons between the molecular energy levels. Okay. This much about spectroscopy, introduction to spectroscopy.